So I'm going to go through section A, linear equations notes. We've already covered this in class. I don't think we finished the notes completely, but I think that we've done most of them, and I just want to go over it and leave a video in case you have any questions for me, okay? So we know that a linear relationship represents a relationship between two variables, right? A variable being a letter, or like an independent versus a dependent variable with a constant rate of change. And so that constant rate of change, right, that's really referring to slope. We remember what slope is, right? And if the graph is a straight line, it always has a constant rate of change, right? A parabola is not a straight line, so it does not have a constant rate of change. That rate of change is always, in fact, changing, okay? So we know how to calculate slope by using this equation. I'm not going to go through it because I know you know how to do that. And then I just wanted to point out two other kind of important things from linear equations, right? So we know point slope form. That is the easiest form when we have a slope and a point and we need to make an equation, right? So we need a slope and a point to make equation, okay? And then kind of the one that everyone knows and I think is the most common that we think about is slope-intercept form. So for that, we need a slope and the y-intercept. And slope-intercept form is y equals mx plus b. And you definitely should have heard that and you know that very well, right? So we need a slope and y-intercept. So then we're going to talk about two things, right? So we have parallel lines. In this right here, I apologize for the typo. That should say perpendicular lines. And so parallel lines have the same slope, right? And do not intersect. So if two things are going at the same rate of change, then you know that they are never going to touch because one isn't going faster or slower than the other. They're going at the same rate, okay? So if they have the same slope, right, you can see 2/3 there, 2/3 there. And that 2/3 is really just talking about rise over run. So it goes up 2 and over 3. And this one also goes up 2 and over 3. Okay, so they both have the same slope, so that means that they are parallel. When we talk about perpendicular lines, it means that the slopes are opposite reciprocals. So we flip the fraction and then we change the sign. So this one right here is 4/3, and this slope right here is -3/4. Okay, and what's important about perpendicular lines, we know that they're perpendicular if there is a right angle between the two lines, right? So parallel, they never touch. Perpendicular, they have a right angle. Cool. So that's all I want you to know about that so far. When we talk about horizontal lines versus vertical lines, horizontal lines, right? The horizon, it's flat. Horizontal, you can think of flat, right? Vertical, think of up and down. Horizontal, left and right, okay? So horizontal lines, this is super important, have a slope of 0. And they have a slope of 0 because there's no change in the y, right? So when we figure out slope, we do y, like the change in y over the change in x. But there is no change in y if the y is the same number for everything, right? So the change in y would be 0, and anything divided by 0 is just 0. So the slope of our horizontal line will always be 0, okay? So whenever we write the equation for a horizontal line, because it goes through all of the same y values, right? So it hits every x value, but it only hits one y value, right? So if we look at this, the equation is y equals 2, right? It's a horizontal line at y equals 2. This point right here is 1, 2. This point right here is 3, 2. Right, so the x values change, but the y values do not. So then when we look at vertical lines don't have a slope of 0, they have an undefined slope. And so very similarly, just how we calculated the slope of the horizontal line, we're going to do the same thing with the vertical line, right? So if we do the change in y over the change in x, vertical lines are different, right? Because it's hitting only one x value, so there's no change in x. So this will be a number over 0. And one of our rules of math that we can never forget is that we can't divide by 0, okay? So this gives us undefined. So the slope of a vertical line is undefined, okay? So again, we can look here. This point is -3, 1. This point's -3, -1. It's only going through, right, one x value, but it's hitting all of the y values. So when we have a vertical line, we write that as x equals something, right? So for a horizontal line, it's y equals something, and for a vertical line, it's x equals something. So now we're going to go through and do these examples, okay, in your notes. And so we are going to write the equation in point slope form and slope intercept form. For some of them, it might be easier to do one way over the other. We are going to do our best with the space we are given, okay? So for point slope form, it's y minus y1 equals m times x minus x1, and then y equals mx plus b. So the first thing we are going to look at here is this first problem. We'll label it 1. So the line with a slope of 4 that passes through the point 7, 2. Right, so what's important about point slope form, it tells you everything you need. You need a point and you need a slope. So they give us a slope and they give us a point. So we are going to use that. So we have y minus 2, because a point is always written as x comma y, equals 4 times x minus 7. I'm going to use distribution. So I get y minus 2 equals 4x minus 28. I'm going to add 2 to both sides. So my line in point slope form is this. And my line in slope intercept form is this. But they mean the same thing, right? They are the same line, they are just written differently. Okay, so now we're going to do the next one, and we'll label this problem 2. So we're looking for a line that passes through the points -2, 7 and 3, -5. So they don't give us the slope, so we have to calculate it ourselves. So the slope equation is the change in y over the change in x. So I'm going to do 7 minus -5 over -2 minus 3. So 7 minus -5 is just saying 12, right? Because when we have minus a negative, that turns into a plus. And then -2 minus 3 is -5. So this is our slope right here. Let me just erase that really quick. Okay, so this is our slope right here. And we are going to use that to plug it into equations. So I'm going to take that and I'm going to go, okay, well, y minus 7, it doesn't matter which point I pick as long as I use the same point for both. Right? And so this is it in point slope form. And then I'm going to do some algebra to get it into slope intercept form. So I have, again, I'm going to distribute. And we shouldn't be scared of fractions. They're not scary. You're going to be okay. Don't worry. So I'm going to add 7 to both sides. And what's important is that we need to figure out what 7 is so that there's a 5 on the bottom. Like how many fifths are 7, right? So to do that, I'm just going to write a little note over here, right? Like 7 is also equal to 35 over 5, right? So y equals negative 12 over 5x. And then I need to add 35 over 5 to 24 over 5, right? And that's a difference of 11. So I end up with plus 11 over 5. So this is it in slope intercept form. Okay, so again, this equation and this one down here are the same, they're just written differently. So next we're going to move on to this third problem, the line with an x-intercept of negative 2 that is parallel to 3x plus 4y equals 3. So first, when we talk about an x-intercept, that's really just saying negative 2 comma 0, because it's where the line crosses the x-axis, right? So the x-axis has a y value of 0, so you know that it crosses at when x is negative 2, right? So the point is negative 2 comma 0. The first thing I'm going to do is figure out what the slope of this line is, and I think the easiest way for me to do that is to put it into slope-intercept form. So I have 3x plus 4y equals 3. And I'm going to move everything over. So I end up with 4y equals negative 3x plus 3, divide by 4. And so it says in the problem parallel. So it tells us that the slope needs to be the same, right? So the slope of our new line is also going to be negative 3 over 4. So I'm going to plug in here y minus 0 equals negative 3 over 4x plus 2. I'm going to multiply everything out. So I get y equals negative 3 over 4x minus 6 over 4. And so this is our line in point slope, and this is our line in slope intercept. Okay. And then this last problem, the key word we want to look at here is perpendicular, and I think we want to set it up the same way we just set up that last one, where they give us the equation, we need to find the slope of that, and then it needs to hit a certain point, right? So if we look at 9y minus 15x equals 8, I want to get y alone. Right? So when it says perpendicular, that means we need to flip the slope that we have and make it negative. So the slope of our new line is going to be negative 9 over 15. Okay? So we're going to set this up in point slope form again. Right? So this is our equation in point slope form. And then we also need to find it in slope intercept form. I'm going to multiply out. It's not going to be pretty, but that's okay. We're not scared of fractions. We got this. Then we need to figure out how many 15ths are in 4, right? So I can just do 4 times 15, and I can use my right? So that's 60. So I have 81 plus 60. So I get 141 over 15. Right, so this is my equation in slope-intercept form. Hopefully this is helpful. We're going to keep moving. And so this question I think is a little tricky because I'm trying to trick you. I want you to understand what the definition is of the things I'm asking. So a vertical line that goes through the point -3, 4, right? So I care about what the slope of that line is. When we talk about a vertical line, I basically just give you the answer, right? So the vertical line always has a slope of undefined. So if the line is vertical, the slope is undefined, right? Because our change in x is going to be 0, and you can never divide by 0. Okay, so whenever we have a vertical line, because the change in x is always 0, right? It's going to be written as x equals, so in this case, x equals -3, right? Because the -3 represents our x value. So then we need to write an equation of the line perpendicular to the line that passes through the point 2, and then passes through the point 2, -8. So what's important here is the word perpendicular. And so for a vertical line, perpendicular is always horizontal. So in this case, our equation is going to be y equals, right? And so it needs to be y equals and then -8, because this right here is our y value. Okay? So the next thing I want you to do, and I think I'm going to do this one right here, number 2, because it's not the prettiest looking problem. So I think it will be helpful if I do it. So the first thing we are going to do is find the slope. So slope is the change in x, or the change in y over the change in x, okay? So we have 45 minus 25 over 20 minus 55. Right, so that gives me 20 over -35. And we know our slope is negative because this line is going down, right? It would be weird if we got a positive slope, you know you'd have a math error. Okay, so then I'm going to plug in any point. So I'm going to do the second point. I'm going to distribute, right, because it wants it in slope-intercept form. And then I need to figure out, okay, well, 55 in 35ths, right? So 55 times 35 is 1925. Just kidding, I may have made a mistake there, right? Okay, so we want to multiply 20 by 55. I apologize, I got ahead of myself there. So 55 times 20 is 11,000 over 35, right? And now I want to add my 25 over. This is where I kind of jumped ahead. I was thinking a little ahead, okay? So I have y equals 20 over -35, x, and then I need to figure out 25 in 35s. Right, so this ends up being and it's not pretty, it's not cute, it's relatively ugly. okay? And then I will do one of the problems below. And you were just trying to determine whether each function could be a linear equation and explain how you know that, why or why not. Okay? So I'm going to first look at the change in x value. So this goes from 4 to 7, right? So that's a change of 3. And this goes from 7 to 13. That's a change of 6. 20 to 18 is a change of -2. And then 18 to 14 is a change of -4. And so I'm going to look at, okay, well, -2 over 3, right? My change in y over my change in x. And then I'm going to look at -4 over 6. Well, that can just reduce to -2 over 3. Because these are both the same, this has to be linear. It has to be a line because it has a constant rate of change. Okay? So try this one on your own. Hopefully these review notes are helpful. Okay? And I will keep them coming.